Good morning, everyone. My name's George Kistler. I work in software quality assurance with Amgen, a little company right down the street here. And my area of specialty at Amgen is software testing tools and processes. And one of the things that John and I have talked about, I spoke at the first FileMaker boot camp back in 2007, and my original relation, I'm getting a date is wrong, error from John. Anyhow, the first topic I talked about was related to hardware, specifically virtualization, because that's what my relationship with data experience is. And this time I decided to talk a little bit about what I do and how it can apply to FileMaker, because one of the things that I've heard through some of these boot camps and other activities is that testing is really not formalized around a lot of the FileMaker processes. And I know this isn't universal, but this is kind of a generalization of what I've heard. So what I'd like to do is I'd like to introduce some topics around testing and talk about how you can leverage testing to drive up the quality, reduce risk, control scope of your FileMaker projects. Sound good to everyone?
Yes.
Yeah? All right. So why should I care about this whole testing topic? Testing has a couple of missions. We're trying to ensure the quality of our application. Quality has a really broad definition, depending on who you ask. We want to work on minimizing our costs of errors. We want to minimize our risks. We want to improve our customer satisfaction, control the scope of our application, and remove as much rework as possible. Application functionality can be divided in two ways. You have intended behavior and unintended behavior. Where they overlap, you get the traditional realm of defects. So you intended the application to do one thing, it did something else, that's a defect. Now, there's additional unintended behavior, which can be things like security defects, other areas that you need to be aware of, but at least this allows you a clear picture of what you're doing here as far as your testing process. Testing is not a sexy occupation in the software world. All right, when it's done properly, it's not visible. It's not something the users see. However, when it's not done properly, it's really visible in a bad way. So let's talk about some recent examples of that. Anyone think of the big one that's in the news all over the place right now? Toyota Prius, little software bug, makes brakes not work right. Kind of important, right? So, and you know, I know FileMaker's not running the brakes on your Prius. You know, some of you guys might be able to actually make it do that, but let's make sure that we keep it in context, because there are liabilities associated. Did any of you work with personal identity data, credit cards, perhaps healthcare data?
Legal data?
Legal data. So there's liability associated if there's problems with that data. So we need to keep that in our mind. The whole objective of this is to mitigate risks. So where does this whole testing process begin? We want to start out with the requirements for our application. And requirements can come in a couple of flavors. We can have design requirements, which are really written for development teams. Design requirements specify things like masks and formats. All right? Then there are business requirements, and these are written at a higher level, which basically describe how the system should be used. Then there's another class of requirements that's widely ignored, non-functional requirements. These requirements basically cover things like performance, security, reliability rules, traceability, and audit trail. These don't affect the functionality of the system, but you bet they're important from a risk perspective. So some of the types of requirements that we can see. We can have system shall statements. System shall statements cover functionality, basically a single function. The system shall display dates in year, month, day format. All right. cases are more common in the business requirements of a system. Those cover end-to-end, what's the business process for using this system. And if the organization you're working with is not real mature, one of the things that we can have is process flow diagrams. Almost every company has diagrams of what their process is. You can tap into that and use those kind of as a springboard for a set of requirements if you don't have a formally documented set of requirements. I advise getting your requirements documented because that helps you control scope. If you work off the process flow diagram, it's really easy to say, that's not what I meant, or that's not what I intended for you to test. If you work off the process flow diagrams, you end up at a higher risk than if you work off of a written requirements document. So, how do we scope out our testing, and what are we doing here? The first thing we need to do is work out a test plan. In the test plan, we should cover some objectives of our testing. We should not only include what we're going to be doing, we should include what are our rules for entering this testing phase. Do we require a functional build? Do we require a piece of a build? Do we require a fully integrated system? Do we require a partially integrated system? All right? Those are examples of entry criteria. Exit criteria may be something like, we've resolved all the defects for this particular phase of testing.
George, when would you decide that in the life of a project?
So usually the testing phase occurs early on, or the test planning phase occurs early on. You want to do that about the same time that the requirements are stabilized. Okay? The next step is scoping the testing activities. So what's really important about the scope is you want to break it out by phase, so you have a clear objective and clear scope for each phase of testing. And then you want to include not only what will be tested, but what will not. So if you're going to exclude something from testing, you need to be very specific and get the buy-in from your clients on that. And you know, that usually means you have to have some pretty sound justification for why you're not going to be testing it. Another piece that's important in your test plan is test logistics. So these are things like, if you have a test environment, which test environment are you verifying against? What operating systems are you verifying against? Are you verifying for Mac? Are you verifying for just Windows? What version of Windows? Right? The test plan should also capture the types of data used in each of these phases of testing. So if you're going to use user-generated data, great, say it in the test plan. If you're going to use migrated production data, do that too. You should also have a high-level schedule as part of your test plan, saying that this is the order that things will occur. And if you're working in a regulated environment, reviews and approvals are very important. In general, you should specify who is responsible for reviewing and approving your test assets. So that's your scripts, your executed scripts, signing off that your defects are fixed. You know, these are good practices, and it makes your customers have more confidence when they see that you're fixing things. It also lets them know what you're doing. So let's look at our first phase of testing. It's called unit testing. And you can look up definitions for these in Wikipedia, a lot of other sources. These are all pretty industry standard things. I'm not telling you anything proprietary or specific here. So unit testing is really modular in nature. We're going to test out individual program functions, and we're going to do it at the code level. So we're going to look at the code, and we're going to take the smallest executable pieces, and we're going to either use drivers or stubs or other methods to stub out that code and say, this little piece works. All right? You can also do this with breakpoints.
What's a stub?
So a stub would be like a little program that feeds data to a module. Okay? So if you have